Hi, Chiti.
Hi
Is your
Sachin.
name pronounced as Chiti or Chiti?
Chitti, yeah.
Okay. Thank you.
Yeah, no problem. I think this week was a very stats heavy week. So,
True. I think Suhail sir has bombarded us with all those
yeah,
equations and data and analysis part. Today I just finished that second chapter of data visualization and analysis. I am yet to cover the next week's data
yeah.
in my curriculums.
Yeah, sometimes the stats and math and everything gets to be a little bit tough, but for me, I feel the easiest way to wrap my head around most of the new concepts is to actually have your own data or
Mm-hmm.
some data that you are playing around with. Then you can relate to what is happening better.
True.
So,
Right.
so there are a lot of data sets that are actually available online, and you can just download like an excel sheet with those data sets and do whatever analysis you want.
I just wanted to understand the way there are data, I mean, as you talked about, the way
Right.
there are data sets for maybe texture analysis or the convolutions and all these things for other, I mean, um, the machine learning programs. Are there
Right.
similar data sets available for the birding data, I mean, the bird related or another ornithology related
So,
data?
yeah, that's actually a good question. I don't know of, I haven't personally used any data, but most of the data that is online, especially linked to papers, most of them are freely
Hmm.
available.
No.
So, if you go to any paper, you will have like a supplementary information sheet, and in that
Mm-hmm.
supplementary information sheet, you will have an Excel table or something like that.
Okay.
So, they share, usually in most of the papers, they share the entire data.
Oh, now I remember. I think again the eBird or Merlin database will also be available to download, right?
Yeah, I'm not sure, but if you like pick some paper, like for example, it is a paper on like
I got that point.
foraging
Yeah.
behavior or something, they'll
Mm-hmm.
actually have like the observations they have made, or if it's like some song analysis, they'll have like all the individuals and all the parameters that they have pulled out for the song analysis from it.
But they will usually put across the result from that data or analysis gist or whatever. So will they also provide a link to that data actually they are using?
Meaning, I didn't quite.
For example, they might have collected tons of data,
Right,
the time and the sexes and the
right,
amount of foraging and all these things. So
right.
that may be constituted or accumulated in a either Excel sheet or
Yes.
something, right? So it may not be feasible to include all that into the paper, but will they be providing a separate link to that data in the paper?
Yeah, so it's
Okay.
actually not in the paper. So if you see like any paper, in there'll be a panel showing like introduction, methods, results,
Right.
everything in the
Right.
web page, and there will be a section called supplementary information, not
Okay.
in the PDF version, in the
I
e
see.
version. And then if you click like, let me see if I can just share screen and show one link. Mm, some paper, it has to be freely available. Uh,
True.
okay, so if I'll just share screen. Hi everyone. I'll just start in a minute. So actually, Sachin was asking. He was mentioning about how to access like some data that is available on birds online, and I was saying the best way to wrap your head around statistical methods is to actually play with existing data. So the easiest way to get some data out of already published studies is to look at the supplementary information that is present in papers. Like here I've pulled up a paper from the lab which is published in Biotropica. It deals with like using area of habitat to assess the extent of protection of India's birds, and this is what your website will look like, the e-version of the paper, and this is the open paper. So if you want to access the PDF, you can click here, it will open a PDF, and if you scroll down, you will see this thing known as supporting information, and then you will find these files out here which are actually the appendix. So this appendix and supplementary information will contain the exact data that is used in this paper, right? And this will be cited somewhere in the paper. So if you copy this and do like search, oh, is this not open? No, I think, oh, okay, this is not open, but you can still access the supplementary information. So if I click this, I can save it, right? Yeah, I can save it. So you can access data from even journals or publications that don't have free access to the papers. And some of the interesting things like iris data set. So the iris data set is very very popular for analysis. So if you go on to like this website, or if you're using a software like R to do any analysis, you can just go to the website and just download the entire data set from like online. So it's oops, it's not sharing that. One second. Yeah, so this is the iris data set. You just do data folder and then you can just like download it. So this is the data set. So if you just download this, you will get basically data of these flowering plants. It is data collected. See, it was donated in 1988, and this is such a famous data set that even if you Google like simple exploratory statistics with the iris data set online, you will get a lot of hits. So iris data set visualization in R. Like for example, R is a programming language, and or even if you do this. So have you heard of this programming language known as R?
Yeah.
Okay, so R is like a freely available programming language. You can download it and start using it. It might be a little bit intimidating at first. If you're more comfortable with Excel, you can download the datasheet even in, it's a CSV file usually. It will open in Excel and you can do whatever analysis you want. Hi Govind, yeah.
Yes, I'm sorry to interrupt. What is that? What is iris exactly?
Iris
This is
data set is,
flower.
yeah, it's flower data. So it's basically the length of petal, sepal, colors, variation, all that you will see in the iris data set. So see, this is an example of the iris data set. You have the ID, which is like the flower number. You have sepal length, sepal width, petal length, petal width, and you have species. So they have about 3 species, and you can do like a lot of visualizations, and the code for it is freely available online. So if you want to play around with different data types, it's all available.
So moving just to answer that question in a short, is that this particular code, what Chit is suggesting or showing, is actually a code written to identify a particular species based on the photo of that particular flower, and there'll be other data along with that, like the sepal length or petal length, all these things.
Yeah.
So based on that, it will identify whether that iris is iris virginica or centrosa or something. There's a machine learning code that it is.
Oh, actually, Sachin, it's not like a machine learning code.
I
This
mean,
this
I
is
mean,
already like fed into the system. So all you'll get is the Excel sheet with all these parameters, and I think it
no,
is probably hand measured since it's donated in
yes, right,
1988.
right. But I mean to say that sometimes I think feeding the what do I say? With this particular, I think they are creating a model which can be fed to identifying the heresy, if I'm not wrong.
Oh, I'm not sure. Maybe that's some current science, but all you're getting right now is this table. So you'll get a
Right, right.
huge Excel sheet with all these variables. So you can
Yeah,
say if I want to check the difference between sepal length in these three species, you can visualize that.
yeah, I think I had downloaded it some time back.
Okay,
Right.
okay. Okay. So I think yeah, let's start. I think we're only 8 people today, very few, but yeah, let's just go ahead. So it's a lot of stats today, and we can go like a little bit slow if you want to. And yeah, I was also telling earlier that it's just easier to understand when you yourself are visualizing your data collected by you or data in a data sheet that you can understand all the variables in. So there are various types of data, and we'll just answer a number of MCQs to see what type of data listed out here, what class it belongs to. So bird habitat type preference in bird habitat type preference, whether it's forest, grassland, or it's a mixed type of habitat, is ordinal data, which is ranked numeric data that has intervals, categorical nominal data, or numeric circular data. Okay. How many people are here? Mm, what about Deepti and Rajeshri? What do you feel? So very important thing before you get into the analysis of any kind of data type is to first see what type of data you're collecting, like what is the classification of your data type. Okay, so the ones who have answered yes, you are right. It is actually categorical and nominal type, right? What about the next one? So, sexing of a white-bellied of individuals belonging to the species in a population, you will result you in what kind of data? Was there a hand raise? Sorry, I can't see.
Sorry.
Yeah, no problem. No problem.
Oh, I did not quite understand. Sexing of white-bellied sulakini. What?
Yeah, sexing means molecular sexing. I meant you're dividing them into like male or female.
Now, what do you mean by molecular sexing?
So,
Is that
so what type of a bird is the white-bellied cholakili like? Can you make out if it is male or female? by
Because it
observing
is
it.
used to identify if it is not physiologically possible. That's what you mean by with the molecular identification.
Yeah, so how would you usually identify if birds are, yeah, exactly. So Harini has said that they are not sexually dimorphic. So, which means that the males and the females don't differ in their plumage or colors or anything, right? During the breeding season or non breeding season. So, they're very difficult to distinguish from the eye. But if you need to know which is male or female, there are different ways to identify it in the hand if you have caught the bird during misnetting, but it's not a very short way, and it might only be apparent during the breeding season. So instead of that, you molecularly sex them, and what you do is you take a drop of blood and you do a lot of downstream lab processes, and you use specific primers that will amplify certain regions of the genome. So females in birds are hetero, like they are ZW, and males are ZZ. So you will see like 2 bands for females and 1 band for males depending on the primer you have used. So that this is molecular sexing. It will be covered in like the upcoming lecture of molecular tools and techniques that are used. Okay, so basically the answer is actually categorical, as majority of you have mentioned. So we'll discuss all the data types once we are done with different examples. Okay, so now average nest temperature maintained during the incubation period. What type of data is this? Okay, Harini says C. C. Yeah, that is correct. It is C. Okay, next question is angular distances of bird observations as you move along a line transit. What type of data is this? Okay, next answers B, C, D.
Ma'am, by angular distances, you mean the angular distances are all measured and carried up, right, ma'am?
In sorry?
By angular distances, you mean all the angular distances are measured, right, ma'am?
Right.
Got it.
Correct. Whatever is measured, yeah. So in degrees, like whatever the degree from the line transit. Okay, so we'll go through all these examples at the end of all the examples, and then we'll go by them one by one. Okay, so actually the answer is D out here, because it's numeric circular data. We'll discuss. Okay, what about this one? What about presence of birds across various elevation types? between, like, in these categories, which is high, greater than 400 meters above sea level, mid elevation from 800 to 400 meters above sea level, and low, which is below 800 meters. Okay, B, C, C. Any other guesses? Okay, so here it's actually B is the correct answer. It is not C, because we'll discuss. Okay. Next data type, weight of birds taken on a digital
Yes,
wing balance. Yeah, hang on, Govind. We'll discuss all the examples. Let's just cover many examples now. Okay, weight of birds taken on a digital wing balance during mist netting and banding procedure. Okay, C, C. Okay, everyone's. Any other choices? Couple of C's, couple of B's. Okay, so the correct answer is actually C, which is numeric interval. Okay, last example. You have an automated recording unit deployed for 3 years in a particular location. Automated recording unit is this device that collects sound, right? And you want to look at monthly variation in calling rates. So here, what is the month? What type of category is the month variable? A, D, 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 A, okay. Okay, so the actual answer is D, it's circular. So now what I'm going to do is I'm going to go to the first question and let's just discuss data types. Yeah,
What's
hang
the
on.
answer?
For the last one, it is numeric D, like circular, for month.
The month is B.
Sorry?
What was the answer for the last one, ma'am?
D,
For the month is.
numeric circular. So
Oh,
we'll
okay.
discuss it. Okay. So now can someone would someone like to give me and explain all these data types? What is ordinal, ranked? What is numeric interval? What is categorical, nominal, and what is numeric circular?
Ordinal rank is like some name or very, we can't compare them. They are sort of individual values, and we can't. Ranking is basic. Okay, so that is categorical. What I was explaining.
Okay.
There's some name values, and then if we have similar type of parameters where we can have individual values, but they can be ranked like high or low or these kind of things. They can be ordinal data. For example, um, size, bigger or smaller or age, something like that.
Right.
And then we have numeric, interval, and circular. The only difference between these is in the numeric value it will be like a normal real number, but you can have variations with that. It will keep on increasing or decreasing, whatever. In case of numeric circular, the data will be similar except that it keeps repeating after a certain interval of time.
Right.
That's the numeric circular.
Right. Yeah. So in this case, when you have bird habitat type preference, you have three categories already given to you, right? Sorry, I don't remember. I noticed that through all these examples, like unanimously everybody did not have the same answer. So I think it's very important to understand this. So you have three categories that are already given to you, and they cannot, so you know they are categories, right? It's not numeric data. You can't say forest is 1 2 3 4 or whatever. Like it does, like it's not like you can have a scale to it. It's a category, it's categorical data, and it is nominal, right? So you have forest, grassland, and mixed, and they can't be ranked. Okay, so it falls under the categorical nominal type of data type. Now, if you have sexing or molecular sexing of any species, it falls into two categories, which is male or female, right? So, can you rank male or female? Like, you can't, right? They are still categorical and they are nominal. They are categorical variables. So, the correct answer out here is categorical. Sorry, Govind, you had raised your hand. Did you want to add something to what Sachin had mentioned?
I want to mention that in circular numeric values, the values are limited so that they often circle back to the original starting point.
Right, yeah. So they repeat themselves. Okay. So now when you have gender or sex, male or female, you have to, it is categorized as categorical data. Now when you have average nest temperature, right, you have it in degrees, and this is in degrees Celsius, and you can go from 0 to whatever level, right? It's not like the circular angular degrees, but since it can be repeated, it is values that can lie on a scale that have a particular interval. Like, yeah, it depends also on the resolution. Either you can have it to 2 decimal points or 3 decimal points, or like no decimal, like 1 decimal point. It is still along a certain interval depending on the device you are using to measure it. So it is numeric data, and it is numerical data which falls along a particular interval. So it is numeric interval data, right? Then when you have angular distances of birds, angles you can only measure angles till about in a circular fashion till 360 degrees, right? If the bird is on the transect in front of you, what is the degree that it will be that you will mention? You're looking straight and the bird is on the line transect that you're walking on. 0. Correct. So then if a bird is absolutely perpendicular to the line on the right as you move ahead, what will be the degree?
90 degrees.
Yes, 90 degrees. So now you're getting the idea, right? So you have 0, then you'll have 90, then absolutely behind you on the line as you move ahead is going to be 180, and so on and so forth, right? So you will get till 360, not till 360, till 299 or whatever, and then it repeats itself. It's not a straight line of degrees ranging beyond 359 or whatever, depending on your resolution. So this is circular data, right? Then
are we considering here minus 180 to plus 180, or we actually go from
I'm actually not sure. I'm assuming there will not be any minus in this, since it will just be like a radial distance from the point as you are measuring.
Radial distance from the so is it so from the line transect we are calculating the distance, right, horizontally?
Yeah,
Or
so if it's
vertically?
so if you're like walking on the line in front of you, it is like 0, and then as you turn towards the right,
So exactly. So it will never go. So basically, if we are really considering right side or left side, then it will be can be 0 to 360 or
yeah,
or
0 to
whatever
360.
range.
But if it is like half and half, I get your point, Sachin. It can be like so the left side will be
Basically-
minus,
Basically, the convention that
yeah,
is there.
and the right side will be plus. Yeah, I get your point. I'm not really sure what is used, and even if I think either of the ways, whatever you use, you can convert it to whichever type you want. So if it's beyond like 180, you will know it's from the left side and not the right side. I don't know actually what is the convention. I haven't done line transects before, but good question. Okay, so now when you have presence of birds across elevations, I think some of you got a bit confused in this part. So the actual answer is it is categorical, right? Because I mentioned it is categorical, but it can be ranked. So I have given you categories, and the categories are specified by a certain range. So irrespective of whether the elevation is going to be like 900 or 1000 or 1200, irrespective of the elevation, if it falls between 800 to 1400, it will come in mid elevation category. And so could you think of why we use why we prefer categories instead of numeric intervals in data types like this?
I have a first question on this.
Sure.
Whether the measurement was about the presence of bird or their elevation. So that was the confusion I had. If it is
No,
presence of bird, it can go to numeric.
it can go to, sorry?
Numeric? How many birds are there? I was thinking.
Oh, no. Presence means like 10. So
Yeah,
if,
I mean, 1-0.
Huh.
Even then, it could be, yes or no. So, are we measuring actually presence or are we measuring the elevation? That's what I
you're
want to
measuring the
understand.
elevation. So if I go out and I'm observing a bird I'm observing a bird, then I look at my, what do you say? What is it?
Right.
Okay, you're looking at your GPS coordinates in your GPS, and you are seeing a column that says elevation out there, and I see that it belongs to 1500 meters. So I write in my data sheet it as 1500 meters and high. But when I'm doing my analysis, I'm only using high, medium, mid elevation and low elevation, right? Is that making sense? Like if I'm
Yeah.
collecting data on a data sheet, but for my analysis I'm only using these ranked categorical observations, ranked ordinal observations, which is high, medium and low. So could you like think of a reason as to why I am not using it as interval data and I'm using it
Because
as ordinal data?
the reason I think could be that uh, it will not be very, I mean, after the analysis of the, to carry out the analysis, it will not be so relevant to have a bird identified at 1404 meter or something like that, because finally you need to consolidate or categorize them or maybe group them or whatever saying, and then if we just go by individual height level, it will be difficult. There will be a lot of those outcomes, right? So, but if we just categorize saying high, mid, or low, it will be easy saying that these are the low-lying bird, these are the mid elevation or canopy bird or whatever.
Right. Yeah. So
Ma'am,
yeah, go with.
could I answer the question?
Yeah. Please go ahead.
Why-
I'm not able to hear. I don't know. My speaker is like really low today.
Well,
Yeah, go ahead.
my answer to the question is it helps studying the birds itself as it is classify them as high or low elevation or mid elevation. We get an idea of the characteristics of the bird other than between the interval.
Rather than sorry.
Rather than very interval,
Sorry, I can't hear you. Sorry. Yeah, and the problem with this recording software is I can't use headphones because then it doesn't capture your voice on the video, and maybe go and just type it, or I don't know, speak little louder if that's possible. Yeah, Govind, are you typing or? There is a high or low to help us understand. The use of high or low to help us understand.
ma'am, can you hear me now?
Yeah, I'm hearing like a lot of honking also, but sure, I can hear you now.
Well, the use of high or low as a category helps understand, helps study the birds, ma'am.
Right.
Because if you have 50 intervals, you say high elevation birds, you can help understand the characteristics of birds. Is that the answer?
Right. Yeah. Sure. So if I'm like suppose I'm studying elevational migrants, which basically means birds that migrate up along an elevational gradient. I'm sure you've heard of this term, or if you haven't, you'll probably hear of it in other lectures. It doesn't matter if a bird is moving from like 800 to 900 to 1000 to whatever, right? It's going to move between these elevational bands. And also another important thing is when I'm collecting data, so let's again take the example of mid elevation. If I have, okay, so for this entire study I have recorded the observation of let's say 1000 individuals across maybe let's say 20 species. Okay, and if I look at my mid elevation data type, I have about, out of the 1000 I have 500 observations in mid elevation across these 20 species. Not obviously the same, but in my mid elevation itself all my birds are concentrated only in the 1000 to 2000 range, or at like 1000 to 1100, right? Like if of the 500, if like 300 birds are in that band and the rest of them are like randomly distributed, if I take individual intervals between like of 100 there'll be like so many intervals with no data in it, right? And that is not going to work well for my analysis because it's not giving me a picture of birds present in these high, mid or low elevational bands. It's going to tell me birds present across I don't know, elevational gradient, but not really painting a good picture, right? So I might have, for example, I might have seen a Sholakili at let's say 1000 meters, and then I saw one Sholakili at 1500 meters, but I didn't see Sholakili at like 1300 meters or 1200 meters. Doesn't mean that the bird is not can't be present there, right? It can be present there. So for that you have these particular categories that can be ranked. It's a high, medium and low can be ranked. And I think Sachin also mentioned like age. You can have like juvenile, sub-adult, adult, like different types of things, categorical variables that can be ranked. They fall under the ordinal ranked data type.
For the purposes of any other study where I actually require data for, say, every, I don't know, even maybe 10 meters or something, there
Okay.
I would be able to use it, right? I mean, for the purposes of this study where you don't really need it at that granular level, you would probably just rank it as high, mid, and
Yeah.
low.
Sure, yes, sure. Like for example, so all this data, even that you're analyzing or using or categorizing, it's based on some inferences from previous papers that you have read, right? So you are having some background to what you are doing, and you look at how literature so far has cited this and what makes the most sense. It doesn't make sense saying that Sholakili is present at 1000 meters and Sholakili is present at 1600 meters, but not in between, right? So based on your study you might see this, but based on my study I have found it to be present at 1500 meters also. So it's not painting like a nice picture of like a distribution of the bird across elevational gradients. And even if you read papers on elevational gradients, you'll see like they have been dividing the mountain in whatever. So even like in strata of forest, you have understory, you have mid-story, and you have canopy, right? They don't say like 1 meter above the ground, 2 meters above the ground, 3 meters above the ground. So if that makes sense. But if you're looking at like, suppose, I don't know, I can't think of an example, let's say insect abundance, and you want to see exactly like the location of these, or let's say I think there are a lot of studies on like crickets and where they call in the canopy strata. So if you, instead of categorizing them as low, medium or high, you want to measure like the exact length, distance from the ground where they are calling at or vocalizing at, or vocalizing birds also at perch heights, then probably you will use something like what do you say, continuous scale or something. It all depends on how your data is looking like based on your classification. If that makes sense, Rusbe.
Yes, it does.
Yeah.
Thanks.
Okay. Okay, so then you again have like weight of birds. Now weight of birds is, again I mentioned, like you're taking it on a digital weighing balance, so you're going to have numerical data. So this is actually numerical interval data, which is on a linear scale. Of course you can't go negative. Then you have this ARU data that has been deployed. So since months are circular, right? So I've deployed this for 3 years. Let's say from one time point to exactly like 3 years. So I'm having 36 months, and months are circular, right? You will have 3 Januaries, 3 Februaries, etc. So it is so it's probably not numeric, but it's, I guess, like categorical circulars because it repeats itself. Yes, Govind.
Ma'am, I have a difficulty. The question is, what is a month in this context, right, ma'am?
So month here, if I'm saying what are the calling rates across the months. So for example, if I'm taking I don't know, magpie robin, I'm trying to see in which month it calls the most. So I'm actually screening through the data and marking every time point it calls, and I want to see the monthly variation. And once I get an idea of monthly variation, I can do something like seasonal variation, etc., etc.
Yes, that's my doubt. That not, even though months are circular themselves, by themselves months are circular, like January to December every year. But in this context, the bird calls would slightly variation between months.
The bird call, sorry.
The bird calls would have a variation in the succeeding month. Like even the first January and the second January would have different variation in
Sure.
calls, right?
Sure.
So in this context, month isn't exactly circular because there's a variation in each succeeding month. So I felt it's more categorical this way.
Oh.
In this context.
Oh, I see. I see.
Mode,
Okay, so like suppose you say average monthly calling rates. Yeah. Or total monthly calling rates. Well, the idea was just to mention that the time point repeats itself. If that makes sense.
sure, ma'am. Well, I felt that the measurement of call rate would be more important.
Sorry.
I felt the call is more important than the month itself. That was my.
Oh, the call. No, so yeah, I can test whatever I want, right? The call. You are testing the call against the month. So you have predictor variables and you have response variables, right? So here my response variable is the calling rate, and I have month as my predictor variable. I mean, it can be significant or not significant. That is irrespective. So I'm saying like the month is important in predicting the calling rates of the bird. Forget about any biological significance to it, or even let's say like some time of the day. Let's say time of the day, right? So across multiple time points in a day, I'm looking at like hourly calling rate, something like that, across 24 hours. Yeah.
Sure, ma'am.
Okay. Okay, so now that we have an idea of different calling, different data types, I'll just move on to the next question. Okay, so what are the three measures of central tendency that are most popularly calculated? Right, and what is exactly mean median mode?
Mean is the normal
Starting
average.
to
One. Yeah. Let's. Vikas, do you want to have a go at it?
Yes, ma'am. I am just answering the question.
Yeah.
That these basically for the data calculation regarding mean, median, and mode.
Right.
Basically, statistical analysis for any type of evaluation regarding bird evaluation or any plant community.
Right. Sure. So, what is actually mean, median, or mode? Yeah, Govind.
The mean is the average of the data. The median is the center point or the middle point of the data, and the mode is the frequency, the number of times of a particular data.
Yeah, correct. Okay. So, yeah, even Harini has said mean is the arithmetic average. That is correct. Okay. So, here you are provided with the nesting data for 10 individuals out here, and I want you to calculate the mean and mode for the given data set. You can just use Excel, or yeah, some things should be like very apparent. So, here you have bird ID, which is bird 1 to 10, and then you have number of eggs that are laid. Okay, we have some answers coming in. Okay, we have mean, median, and mode calculated. How is the mean varying? I'm not understanding.
How do you calculate the median again?
No, I'm just asking for the mean and mode for this, not the mean, median. Yeah, you can do it in Excel, like, or just use the formula for quartiles. I can't remember the formula.
I think I'm missing one later, that's why.
Right.
Formula for
There is actually one letter missing. There is no bird 7 here. So that's why later
Oh,
corrected
there
it.
is no bird 7. Nice. Good spot. Yeah, so then I think Sachin is right with the 3.77 trick question. Yeah. Yeah, watch out for these types. Okay, so basically how to do mean is you total the number of observations and divide it by the sample size, right? So you do 4 plus 3 plus 4 plus 4 plus 3 plus 5 plus 2 plus 4 plus 5 plus 4 plus 3. You median, yeah, I don't know what's the calculation. I would just like use Excel and do median. This basically it's midpoint. It shows it's 4. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it shows it's 4. I think you have to arrange this in ascending order and then see what falls exactly in the center. But there are different formulas to calculate. So the median here, yeah, Sachin's answers are right. It is not divided by 10, it is divided by 9.
9.
Yeah, correct. Right, and the mode is very easy to figure out from this observation. You just have to see, so you can categorize them. So number of individuals that have laid 2 eggs is equal to 1. Number of individuals that have laid median is 4, that is correct. Number of individuals that have laid 3 eggs is equal to 2. Number of individuals that have laid 4 eggs is equal to 4. 5 eggs is equal to 1, right? So the frequency with the maximum frequency, which is the most number of individuals that have laid a particular kind of egg type or number of eggs, is 4. Right? 4 individuals have laid 4 eggs. So that becomes my mode. Is this clear to everyone? So,
Yes, ma'am.
okay. So we can just go to the next
If
question.
you happen to know the formula for median, I can find it.
Formula for median. Let's see. Is it not there in the lecture? Okay, if n is odd, if n is even, if here n is odd, it's x into n plus 1 divided by 2, and x is actually the ordered list of values in a data set. Mean calculation data set. Okay, I'm just gonna look for a link and pass it on to you. Meanwhile, so you actually look at the middle value. Here, this has a table with the value of very simple calculation of mean. Multiple examples are there for even number of data and odd number of data observation points. So here it is odd number of observation points. Okay, so moving on. Right. So so here out here you have a graph, and you have number of eggs per nest shown out here, and you have a frequency. So what is this actually showing us? Would anyone like to take a stab at what is showing us? Mode is 5. Yeah, that is correct.
How
Mode is
many,
5. Yeah.
so it's how many birds have that many number of eggs in the nest?
Right.
So what is the frequency of from a population that has
Right.
the eggs on the x-axis?
Right. So if I take the first bar, what is it actually showing me?
Approximately 3 where have laid 1 egg, 1 nest.
Exactly. So frequency is basically the number of birds that have 1 egg in the nest is approximately 3 birds. Same as that number of birds that have 2 eggs in a nest is about 3 birds. And the total, what is the maximum number of eggs that a bird can have in a nest based on the data given?
16.
Uh,
Sorry, maximum number of eggs can.
Yeah, so it can have 10 eggs, right? So you can range, there are no 0 eggs. So all the birds that have built a nest have laid an egg, and you can have the number of eggs in a particular nest ranging from 1 to 10, right? And then you can see the number of birds that have a particular number of eggs per nest in their nest. So out here, as Harini has mentioned, the mode is very, very evident out here. So you have 5 eggs per nest, and you have maximum number of individuals having 5 eggs per nest. It's about like 16 odd individuals, and that is followed by 6 eggs per nest and then 7 eggs per nest. So these 4 values, that is 4, 5, 6, 7, seem to be the most common number of nests, eggs per nest, right? And if I were to find so can you tell me what is this data chart called?
The bar graph, the bar chart.
Okay, sure.
And frequency distribution, basically the
Yes.
histogram trend.
Yes, correct. So it is a frequency distribution and it is a histogram, right? So whenever you have any data, It is definitely a bar chart. So whenever you have any, and you can also divide this into bins. Okay, so if you have 1 to 2 eggs, that can be one category. 3 to 4 eggs, other category. 4 to 5 eggs, not 3 to 4. 5 to 6 eggs, another category. So you can have various categories as well. And one of the easiest ways to visualize your data is using a histogram, which would look something like this, and you'll see the distribution type. And if you see it is a bell-shaped curve, what would you call the distribution of the data, like is shown out here?
Gaussian distribution. The normal.
Okay. Yeah, exactly. So I think, yeah, that is the term. I'm not sure if Gaussian distribution has come up, but yes, it is a normal distribution, right? Which you have a bell-shaped curve and you have a peak, and then you have like some outliers out here. So you'll have a normal distribution. So even if I'm collecting data like, for example, wing length, or yeah, Govind.
What did you mention, ma'am? Normal distribution? I didn't get that.
Bell-shaped curve.
So,
Yeah.
is it a normal distribution?
Sorry, Govind, I didn't quite catch what you said.
Ma'am, what do you mean by a bell-shaped curve?
What do you mean by normal distribution? Is that what you asked?
What do you mean by a bell-shaped curve? Normal, yeah, normal.
Oh, so the curve is. One second, let me just mute because I'm unable to mute. Okay. Yeah. So the normal distribution means it will follow. Where is like? Oh my God, who is like unmuting? I don't know why this is echoing. Okay. So it follows a pattern that is like this, right? You'll have a peak on the top in the center, and then you will follow like a curve that is almost like, if you fold it in half, it will be like it'll overlap itself. So it's a bell-shaped curve, and a normal distribution usually follows this. Sometimes you might have your data that is skewed to the right or skewed to the left, where you will find like a peak towards this side if it's skewed to the right, or you will find a peak that is skewed to the left, which is like this. So most of your observations will be around 1, 2, 3, and it will go tapering down like that. So it is just like a usual visual characteristic of it, but there are several tests for you to do that can show if it is if your data is normally distributed or not. And based on whether your data is normally distributed or not, you will do your further downstream analysis. So you have things like parametric data, non-parametric data. If the data is normally distributed, you will follow like parametric data analysis. And if it's not normally distributed, you will use non-parametric data analysis. So we need not get into details and get confused over things, but yeah, all you need to know, like, it's a normally distributed curve. And I think Suhail's lectures are very well detailed in visualizing this type of data, and also analyzing it. So even if you are not able to get it in the first go, probably look at some other examples and revisit the lectures again, and you might understand better.
Right, ma'am. And the median for this is 6.
Median for this is 6. Based on, I am not exactly sure because I don't have the values for all the observations, but yeah, sure, if you have calculated it based on whatever is being tabulated, probably, I'm not sure.
Not ma'am, actually that is not mean on median. Here in normal distribution curve, generally we show the density of any population, any
Right.
plant and any species. So in normal type of distribution, if any population show normal type of distribution, then it is a good size quality basically. So in this graph, basically statical data not present. Density and other is put up on there.
Not really. So like when in fact, like for a normal distribution, for a data to be normally distributed, and usually when data is normally distributed, you have your mean, median, mode to be equal.
Okay.
Yeah.
Okay.
So I think there are like a bunch of graphs. I don't actually have it now, but it will show you like the mean, median, and mode. If they are aligned, it is exactly a curve that is can be folded in half. But if the mean, median, if the data is skewed, you'll see the mean, median, and mode falling at different places. Okay.
So for I think even numbers, it will be the average of the central two numbers, right? Or
Uh,
median.
so
Mode will
yeah.
be obviously with the maximum.
Yeah, if it's like perfectly symmetrical data, then it would be like the center. But if your data was like this, skewed towards the right, you would have your mean towards this area probably, and then
No,
your
but will you actually, I mean, if you have to find the median for this
yes,
one,
yes.
will you actually say 6 or average of this thing?
Because it is even number of observations. I actually don't know what is the total.
Because the formula says average of this middle two, that's why I was
No, you'll have to total all these. So it'll be like 3 plus 3 plus 4 plus whatever 11 plus
median is
this
basically splitting your graph
data
into
into half. Correct.
So now there is no averaging principle here. You don't consider all the values, right? What is at the center is 5 and 6.
Yeah. Oh, so you're asking whether it will be a value between 5 and 6 or
Yes.
oh that I am not sure.
Because what I looked up about the odd or even numbers, for
Right.
odd numbers it will be the central number.
Yeah.
But if it is
Even it is
even
the
numbers,
average
it is
between
average
the middle two numbers, right?
Yeah.
Yeah, but out here you will have to. It is not. It's the average between the observations, right? So you will have to see where. I don't know what are the total number of observations in this. If there are like 70 or 80, so it will depend on that. I'm not sure of the total, but I'm assuming yes, it should be probably between 5 and 6, since this seems to be kind of normally distributed. I mean, if that's clear or not. So if I had a data that had a peak out
You
here,
basically is trying to say that 1, which is having frequency of 3, you will plot that as 1, 1, 1, right? And
yes,
then
correct,
that's what you're saying.
and the midpoint of that, whether it's like the 35th or 36th observation, whatever it is, the total number, then the midpoint of that.
Yeah, but assuming that if this was actually not the frequency distribution, but generally the XY part,
Yeah.
normally then
If your
I'll say that
35th, if let's say it is 74 or whatever, 70 observations out here, then your, 35th and 36th, the middle of that, average of that. Yeah. Okay. Right. So why is calculating a median important and not the mean? Like in cases like why should you calculate a median if you can calculate a mean?
it depends on the study that you are doing, and as I think Suhail sir had mentioned, sometimes if there are some outliers in the data, it may skew the mean.
Correct.
So other points like mode or the median may skew the mean stable,
Correct.
sort of unaffected or least affected by those outliers. And that's why I think can give us reliable data.
Right. Yeah. Yeah, that's absolutely correct. So when you have sometimes skewed data, as Sachin mentioned, like when you have a distribution that is centered around the left side or the right side of your plot, then you would find the median, since it's the exact midpoint, you will find. Yes, Rosemary.
Sorry. The
Oh.
only question I had about this is when we are literally looking at these simple examples, it's very clear.
Right.
10, say a frequency that is generally not very wide, and one is obviously an outlier as such.
Sure.
But when you're really working with a lot of data,
Yeah.
how do you take a call whether it should be the mean or the median, and how do you take a call whether the mean is very, in that case, not
Yeah.
giving you the. So, is there a kind of mathematical or a
Yeah.
kind of standard?
I actually don't know if there is a consensus on anything, but usually if you read papers, it is not sensitive to large data. Rajshri, are you mentioning about whether using the mean, median, or mode? Actually, that actually might be true because you have, but sometimes yes, in skewed data, even if it is quite large, I'm not sure as to how far apart the mean, median, and mode would be. But you usually see people only referring to means in papers, and then you have like standard deviation or standard error that is mentioned alongside it. So that seems to be like I don't think there's any written rule. It's like, yeah, most
Maybe
common.
you calculate both, and if you realize they are very far apart, then you rely on the.
Probably. Then you will mention both. Yeah.
This is the exact question, or maybe the similar lines I asked the same question when I was going through this lecture on linear regression. How do we basically identify whether there are actually outliers on the data that we have captured, because those might deviate our line that we try to take as the regression line, which can minimize our errors or something. So
Sure.
I still don't have an answer to that point.
Yeah, that's a good question. So like let's take an example, let's say, and I want to measure the wing length, let's say, for the white-bellied cholakili, right? So this is probably like a very crude example, but if I go to only Kodaikanal and measure the wing length of 30 individuals, that's not going to be a good representation of the population of the Sholakili, right? So I increase my sample size, and if I feel like wing length is usually between like let's say 60 to 65 mm, and I do it across the entire landscape gradient in 10 locations across like 30 birds for every location. So I have 300 birds across this entire distribution area of this particular bird, and if I see that there is only one or two birds out of these 300 birds that fall in maybe like wing length of like 50 mm or something like that, it is an outlier. Right? So increasing your sample size is definitely better to figure out what is an outlier or not.
But as you said, your example is good, I understand that, because you're actually measuring the length of the wingspan, right?
Right.
And there you may have extraordinarily large wingspan or something, which is
Right.
still true.
Right.
You can't
Correct.
eliminate that as an outlier, right?
Yeah, so the thing is you don't so okay, so good point.
I mean, I'm trying to say the observed data versus some, I don't know.
Sure.
Whether there is an error or not, that is what I'm trying to
Oh,
say.
measurement error you mean?
Right? Right? I mean, we are assuming that there is no measurement error.
Correct,
But
correct,
we
yeah.
got data from different entities.
Correct.
They might have done some error while uploading the data or recording the data.
Yeah, you are absolutely
And
right.
then at the end point where I'm analyzing that data, I don't know what are to be categorized as outlier and what are not.
Okay, yeah, fair enough. I think very good question out here. So the point that Sachin has brought up is like measurement bias. So either that can be due to using a different instrument every time you are measuring, or changing the person who is measuring, right? So usually when we take measurements in the field, we take 3 measurements for every length. So I'll take wing length 3 times, and it is me, and to minimize the observer bias, only I will be taking all the observations with my particular scale or ruler. So that kind of reduces the bias in that. And if there are multiple observers, you can also include like observer as one of your variables in predicting wing length and seeing whether there is a high degree of variance between observers in measuring a particular individual. So in an ideal situation, what you will do is one bird which is measured across 6 observers 3 times. That is like gold standard. But there are ways to minimize error. And of course, a lot of people do delete data or eliminate data if they are outliers. But if like there are various ways to like clean your data, etc. Like for example, if I see like a weight of the bird is 35 kilos, 35 grams. Oh God, what am I thinking? It's of a white bellied cholakili. Like it's impossible, right? Like even if a bird has like 2 eggs inside, it's probably not going to be like 35 grams, because a bird normally weighs around 25 grams, and an egg is probably like, I don't know, 3 to 4 grams, right? So there are some things that you can for sure mark as based on observation. So you need to have some background to it. Yeah, but there can be birds with extraordinarily long wings or short wings, and most often they will have short wings when they are in molt. So the time at which you're doing your observation also matters a lot, because birds shed their feathers at some point of time during the year, and if you're taking it at the point of time where it has not grown its feathers fully, your wing length will be different. So it's just based on whatever background we have of the bird and when we're collecting data. So all those factors do matter. Yeah. Okay, so I think we already did mean is equal to mode, what it means. So it means that, yeah, the data is like normally distributed. Okay, let's go to the next question. So a 95% confidence interval for the mean of a population is such that it contains 95% of the values in the population. There is a 95% chance that it contains all the values in the population. There is a 95% chance that it contains a standard deviation of the population, or there's a 95% chance that it contains the mean of the population. Oops. I think I have like messed up the question itself, but yeah, sure. Okay, B. Okay, so the answer is actually in the question itself. It's actually D. There's a 95% that it contains the mean of the population, not actually the values, it's the mean. So the answer is actually D. So 5% is that the mean, there is a 5% chance that, yeah, Govind?
What do you define as a confidence interval?
Sorry, I cannot hear you.
Do you give the definition of the confidence interval?
A confidence interval, so it's a range of values between which with confidence you can say, so you have like different cutoffs, so you can have like you have this alpha value or beta value or something like that, and then you can say with 9, if your value lies between the confidence interval, it means that there is a 95% chance of your value lying within the range, right? So if it is outside the range, it is an outlier, if that makes sense.
Okay.
So it's like you're saying like the true value of the mean of the population falls within a confidence interval range, and if it is beyond that range, then for example like your there is another value that is calculated, it is like the p value, right? And if your p value is lesser than 0.05 or 0.01, you can say that it is highly significant that the means between both the population are different, right? But if it is greater than 0.05, you will say that the means of the population are the same. That means population A is not different from population B. This is in the case of comparing two populations for whatsoever value. And that will lie, your means will lie within a confidence interval range that is measured by whatever 99% confidence interval or 95% confidence interval. If your value lies between that, that means that with this much percent confidence you can say that it belongs to this population or that population based on the means of your A and B population. Yeah, I think I can also like pull up some videos for explanation if that will help, but currently I don't have any of them. Yeah. Or we can do like some we can actually do some examples with data in Excel, so I can share like an Excel screen and we can manipulate the data and see how values are falling in or out of that depending on whatever we are trying to calculate. Okay, so when we do sampling with replacement, it is known as bootstrapping, jackknifing, shoestrapping, or machine learning. Okay, so all of you have said correct. It is B. Oh, jackknife is actually like a technique of sampling. Yeah. Anyway, so does anyone want to explain what is bootstrapping?
You have some sample data,
Right?
and then you basically randomly like pick up some samples and populate that within the same data. So you increase basically the samples virtually,
Right.
and then you can then try to sample data from that new set, and you can keep continuing doing this, increasing the total samples,
Mm-hmm.
and then can randomly again sample the data which may be equal to the number of samples that we had here, and then try to get the means or other parameters from that data. So basically the bootstrapping is populating the same data randomly from the same set of samples.
Right. Right. So basically, it involves replacement, and you can sample, like if I have 300 points and I'm doing bootstrapping of like 100 values or whatever, I will sample 100 values from the existing 300 values with replacement, and I'll do this like 1,000 times. So that will actually give me a result of, and I'm calculating like the mean for those 100 values, but my mean for those 100 values will differ depending on which are the values I am choosing, right? But when I say with replacement, I can repeat the values again, and that will give me a distribution of, like, of the means of those 100 values within this sample set. So it is actually a measure of like precision. Statistical procedure in ornithology helps you calculate standard error and confidence interval. Yeah, correct. Okay, not in ornithology, in any stats, in any sampling. So actually, you have different techniques. Yeah, Govind.
Ma'am, I didn't get the explanation of bootstrapping.
So it's random sampling with replacement. Like for example, if I have 10 observations and I want to find out what is the mean of 2 observations, I can pick the first and second value, then I can do second and third value, first and third value, right? I can replace the observation. So I can use the observation again in my sample set. Does that make sense? Because like in some cases, like for example, like jackknifing or something, I'm not even sure if I'm exactly saying it correct or not. You have to knock out one of the sample sets. So you do like 3, then 2, then 1. It depends on your data set and what you are trying to do. But bootstrapping means like you are repeating like those particular sampling technique multiple times. It goes over multiple iterations. If that makes sense. No? Govind?
Yes, no, I somewhat got it.
So you will get like a frequency distribution, like what we were saying, right? So you will have like the frequency distribution of the two, the averages of the whatever 2 or 3 numbers that you are choosing. You'll have, and the more the number of iterations you have, the more tight your means of the bootstrapping technique will come. So if you have it actually measures the precision and shows you like the confidence interval, as Rajeshri has also mentioned. So if you look at like, I think the lecture notes or the lecture, what is it? I think it's lecture 1 of data visualization. Like Sohail has mentioned that sampling with replacement using pieces of paper in a basket, right? And you do this multiple times and you calculate the mean of the bootstrap sample. So he's done this like 1,000 times, and you end up with a frequency distribution curve. So when you have like an original distribution versus like the bootstrap distribution, you will see that the spread is much less and it follows a kind of normal distribution. Right? Instead of taking 5 samples once, 6 samples once, 7 samples once, 8 samples once, he's taken like 5 samples like 100 times to find out like the mean paper size or count. I think probably Govind, like a video example. I'll look it up. I'll look it up and see if there are any good ways of explaining this, or we can just do this like in the next class. I can like show you some videos. Okay, so what is the difference between standard error and standard deviation? So everyone knows how to calculate standard deviation, right? No?
So we have variance,
Variance, yeah.
which will be like value minus means square of the value minus mean by degree of freedom. Then summation of this thing for all the values will give me some uh, unit squared value, and then the standard deviation will be the square root of this variance.
Variance, yeah. So, yeah, square of standard deviation is actually variance. And oh, actually, I don't have like the formula example out here, but like we did this in the previous lecture, right? We did mean minus the value and divided by the sample size, and the square root of that was the standard deviation. So you're basically checking what is the spread of your data, and it is a measure of dispersion of your data set that you have. So in if I'm doing a number of plots, I want to see the standard deviation of the presence of standard error is an indicator of the precision of the mean estimate. Yeah, so it's actually standard error of the mean, that is actually correct, and it is also at the population level. So you're finding out the standard error of the it's an estimate to see what is the standard error of the population's mean, not the sample's mean, right? So if you have across a sample's mean, it is known as standard deviation, how spread out your data set is. And usually you don't measure spread just based on the values itself, you measure it based on the standard deviation, how many standard deviations away is it. So you yeah, I don't know if this is like getting more confusing or not. I should have probably like done a video approach to this.
Probably it's like something, if I had a data, then I do calculate the deviation of the data, standard deviation of the data.
Yeah.
But then if I go back, I mean, I'm just trying to understand if it's correct or not.
Yeah.
If I try to bootstrap that data and do calculate means of that, all the data that are sampled newly with that random sampling,
Yeah.
and then I try to calculate the standard deviation of the mean, that will give me the standard error.
Yeah, sure. Yeah, you're increasing your sampling across your population, and then you will get a standard error for your population level estimate.
Yeah, and that can give us the confidence level as well. What is the
Sure.
range of-
Yeah. Yeah, that is right. That is right. Yeah. Yeah, I don't know if that helped in understanding. So I think even Sohail has mentioned that it can get confusing when they interchange and use standard error and standard deviation. But one of the most important things to remember is that standard error is used for a population level mean, not your sample, the sample means, right? So it is the mean, standard error of the mean is a standard deviation of sample means over possible samples drawn from the population. So when you do a standard deviation of means, you get to standard error. I think formulas would help, but that might also cause more confusion. But as I said, we should take like a data set and calculate all these values and then see what is actually varying between those calculations, right? So when you do standard error, when you do So usually when we use like analysis softwares, we just get like a value out, but it's difficult to visualize unless you try and get all the values and then compare it and then break it down to the formula for calculating it. Okay. So what is a Z distribution and why is it important? Anyone knows what the Z distribution is? So when you're calculating like t values or a t distribution, you will have like Z scores, for example. And basically, if you're seeing like a lot of spread between your data, you do something known as a data transformation. And out here, when you do the data transformation, it reduces the spread of your data. So instead of you having a normal distribution where the value of the mean is let's say, like for example, the nesting data that I showed you, the value of the mean is around like 5 or 6 or whatever, you will find that the center of your normal distribution is actually 0, and towards the left and the right you will have positive and negative values, and it becomes like a standard deviation. You'll have a standard deviation of 1. So that is how you have a Z score that is calculated. It is measured in units of standard deviation and not the actual absolute value. Right? So the Z score actually will tell you how many standard deviations away from the mean your particular value is. So if it is like 3 standard deviations away from the mean, that means that when you see papers, you will see mean plus or minus standard deviation for certain data sets, and it shows you how far the data is spread. So if the mean is like plus or minus 2 standard deviation, plus or minus 3 standard deviations, it shows like your standard deviation is much farther away from the actual mean of the calculated data set. Right? No? Confusing? Okay, confusing, I'm guessing. So do you need like more explanation in these kind of terms? Or like how would you like it to be done?
Yeah, I think gone through the lecture, I understood what the set value or a given or samples is basically. How do they calculate
Right.
x minus x mean by the number of samples of the standard?
The standard deviation for Z, yes, correct.
Yeah, but really, if you really want to help us explain, that would be easier to take some sample or the graph. You can say that okay, this is how it is moving. Or
Yeah.
how is this getting? How it is helping us
Right.
arriving at some particular data that we are looking into, or conclusion or analysis.
Yeah.
Even if there are some videos that can help us
Sure.
with that visualization, that would be great.
Sure. Yeah, Govind.
You could also use the graphs of some kind of concrete examples that are in practice in studies as a way to explain.
Sorry.
You might be able to use concrete examples or papers or researches where these techniques have been carried out as a way to explain.
Yeah, I would say don't get into the papers. These are all very simple concepts that can be extrapolated to anything. So you can just use dummy data and see how things change when you change the values. So don't worry about the significance or not significance, etc. of it. It's just how it is arrived at and why we are arriving at it. So basically data transformation, which is what is actually a Z distribution, it is done when you are when your data is not the data has a lot of spread. Like for example, I'm sure in many graphs you might have seen like log of some value, right? Like you do log transformations of certain data sets because their numbers range from 0 to like 10,000, and you can't really put 0 to 10,000 on a graph, right? And it's not going to show you any pattern if you have 0 to 10,000. Like where is your graph going to go? So you do like a log transformation of it, and to have a better visualization, a better pattern, and then when you want to pull out a certain observation from that, like at this particular value on x, what is my log transform value of y, you do a back transformation. So data transformation and types of data transformation are important when you are doing analysis. And as you go through various data types, you will also understand why certain types of transformations are done. Like sometimes you might find your raw data, the data exactly that you've collected, is not normally distributed, but if you transform the data, it might fit a normal distribution or not. Because like in this case, for example, you are centering it to the mean. So your mean is 0 and then you have positive and negative values. So your spread based on the mean might actually reduce. So this will be more apparent when you are actually doing it with like a data set. But yeah, as you have mentioned, maybe we can like try something that is more interactive or has something like that. Yeah, this is also like pretty technical. So if the population standard deviation is unknown and the sample size is small, lesser than 30, the confidence interval for the population mean is based on, okay, see, okay, yeah, so the answer is actually C, that is correct. It is based on the T distribution. Okay, so when you're making comparisons between data in an unpaired sampling framework between two data sets A and B with multiple observations in each, one must ensure that both data sets have equal number of observations, or one should take the difference between the observations from both data sets and then average them, or one should take the average between both data sets and then take the difference, or you cannot make observations between two data sets like this. Okay, so when you have difference between individual observations from both data sets, you're basically doing A minus B and then the average, right? Summation of A minus B and then the average. Or you are in C, you are actually having the average between both data sets and then taking the difference. This is unpaired. So the key word here is unpaired. So what is unpaired sampling framework? What does this mean?
One thing is that there is no equal samples between the two sets. It is clear. The second thing is that both are not correlated to each other. I mean, each individual sample is not correlated to each other, saying,
They are independent.
yeah,
Yeah, that is correct. So unpaired sampling means that the number of observations in A and B are completely different. The number of observations. Yeah, exactly. And A1 and B1 are independent. So you can't really take an average first take the difference between A and B and then divide it. Like the difference between A1 and B1, A2 and B2, A3 and B3, and then add up all those differences and then divide it. No, that's not going to give you anything. So you find the mean of A, which is A1 plus A2 plus A3 plus A4 plus A5 divided by 5, and then you do B1 plus B2 plus B3 summation of that divided by 3, because they are unequal, and then you subtract the means between both. That is how you would find the mean of an unpaired a study design with an unpaired sampling framework. Okay. So in usual regression analysis, what is usually denoted by the gray area? You can denote a lot of things with gray. You can choose whatever you want depending on the code, but what is usually illustrated? So regression line is basically, you have a spread of points between the x and y axis and you're fitting it, right? You're fitting a line to see where the trend is. And if per se you knock off some point somewhere, you will see that your fit is going to change. Like for like for example, if I remove the points out here and if I remove the points out here, how will my line be? If I fit a regression line, it's going to go like this, right? Because that's going to be a best fit explaining the line. It's not going to go like this. If I eliminate these points above, I don't know what this is, 7 and below 3, the line will go like this, and most of my points will fall along this line, right? Because everything will fit along this line. But since I have like a very scattered representation of my data points, the best fit line is showing a positive association between factor x and y, whatever my predictor and response variables are. And then this gray zone actually shows me the confidence interval. It is not the standard deviation, variance or spread. It's actually the confidence interval that is shown with the representation of my linear regression line. So the actual answer is C. And I think it will be helpful to plot this data. Yeah. Right. Okay, disease time. So what is true about spillover diseases. They can be transmitted from one species to another. They can spread faster than any other type of disease. They are only concerning viruses, or they can be spread even if the source and recipient host do not interact. Oops. Sorry. Spillover diseases. I'm just gonna type here. I'm lost between. Okay. Sorry, I think Govind, I'm not sure if your answer was for the previous one or this one, but yeah. Okay, yeah, so that is correct. This is true about spillover diseases, that they can be transmitted from one species to another. All of the other is not true, because there have been no studies based on any of the things that they spread faster than any other disease. Yeah, Govind?
Can COVID-19 be considered a spillover disease?
Yes, definitely, yeah. I mean, that is what I'm not going to get into the, what is it called, conspiracy theory or anything of it, but yes, it is believed that it came from it is a zoonotic spillover disease. Yeah. Okay, so what is not true about the West Nile virus? Okay, I'm just going to type. Okay, DDA. Yes, Vikas. Okay, so it's actually I should have like changed it to what is true about West Nile virus. Okay, so I think it actually kills like all of them, humans, birds, and horses. But what is particularly interesting about birds in this West Nile virus cycle, transmission cycle? Hello?
I do not know much.
Okay. Okay.
It is by mosquitoes now.
Yeah, it is transmitted by mosquitoes, but actually the birds are an amplifier host. So basically, they allow the mosquito to propagate inside it, but they don't really. I thought that they don't die from it; they just amplify it. But it seems that it's just like a reservoir. But it seems as I was searching, they have reported deaths from the West Nile virus as well in birds. I'm
They
not sure
carry
if anyone has explored this more. Yeah.
the cat.
Sorry.
You need to sell the carrier.
Yes, yes, they are a reservoir for this. So they help the virus develop and spread. And then when they go to horses or humans, the horses and humans are dead end carriers. So it doesn't proceed more from that. So if a mosquito bites a infected horse or a human, it is not able to get infected to carry the vector, I mean, carry the parasitemia to another host. But if a mosquito bites an infected bird, it is able to, and sucks the blood out of it, it is able to take the parasitemia out of it and infect another individual. So that is what it means by a dead end host and an amplifier host. And this is illustrated in Farah's lecture. I think Farah's lecture was included in this week, right?
Right.
Right, yeah, okay.
Just wanted to understand here. When we say, I mean, statement wise, it kills humans, birds, and horses. I mean, does 100% kills humans, birds, and horses? That's what I'm thinking.
Yeah. So I actually thought that they don't kill birds, but as I was searching for papers, I did find that though it is an amplifier host, it also kills birds.
Kills. I understand, but when I'm saying that if 100 birds get infected with the virus, 200 birds get actually killed by the virus.
Oh, I don't know. I think it will depend on the viral load. Yeah, so I don't know if there is a 100% fatality based on just presence or absence of the infection.
So what do we say here? The answer would be
Yeah, this question is like a little bit incorrect, in my opinion. Yeah, the question is incorrect. We could just skip it. Yeah, it is confusing. Correct. Yeah, but let's just stick to the birds are an amplifier host, and the horses and humans are dead end hosts, right? Yeah, Govind.
I just had a question. Does it alter the bird's behavior or something in some way?
Oh, I am not really sure, but I am sure there are some parameters that probably have been studied in the birds that have been infected with the West Nile virus. I am not sure, but it probably does have some effect.
I heard that some bacteria
So,
can often alter the behavior, the traits, the spores, in order to propagate itself even more. Like, for example, I've heard this, some snails infected by a parasite can often be more prone to be eaten by birds, or fish can make
oh,
themselves.
right, yeah. Sure, sure. Yeah, I am not really sure of what if there are any behavioral alterations that are made by the infection of this parasite. But like if you have a paper or something, like yeah, you can share it.
But these examples are mostly bacteria or other parasites, not viruses. So I don't know.
No, I mean you can just search and see if there is anything. I'm not sure, or even I can just search and see if there are any behavioral effects. Okay, avian malaria affect the dash of infected birds: lifespan, reproductive success, body condition, all of the above. Okay, yeah. So, yes, you are correct. All of the above is the correct answer. It does affect all these parameters. So, in most of the studies, what do you think is difficult to measure? Among the. Okay, reproductive success
Lifespan.
and lifespan, right? So because you need to track a particular individual for how many ever years it lives depends on the type of the species that you're studying, and if it is not well studied you'll never know till when it lives, and you can't possibly do your study till like an infinite period, right? You need to have a fixed thing. So most often the infection is measured alongside measurable traits like body condition, and body condition can be taken in a number of different ways, like whatever you are measuring during mesh netting. So there are some things like bilateral asymmetry. So usually birds are or like all like animals are bilaterally symmetric, but you measure like left wing and right wing, left tarsus and right tarsus, and you look for asymmetry between both those, and those have seen to be correlated with infection levels as well. So there are several different morphological traits or traits of body of anatomy or morphology that you can take that can you know show estimate of body condition. And also there are other behavioral characteristics, like for example vocal performance has been correlated with parasitemia load, etc. So yeah, these are like things that are coming up, and we are trying to look for like more and more new parameters that can be used to explain what are the effects of infection levels, especially like avian malaria, in because it's very it's not that it's uncommon, it is quite common. And even if you have seen papers from our lab, like Robin's previous work, they do show infection of even avian malaria at high levels, even like Farah's work, even in the Himalayas above like 2000 meters, etc. Though the infection level is lower, it is like still present till a certain degree, till we go higher up. Okay, I think we are up with time, and probably during like the last lecture we can do some example based statistical approaches, if that would help. So yeah, thanks for joining in, and catch you all next week.
Thank you.
Yeah, bye.